Alright, this is a quick talk on Jupiter. Here I have Jupiter, the Giant Planet by Rita Beebe. Okay, page 59. I notice that their models have Jupiter as being metallic hydrogen, which I think is nonsense, but we'll just skip that for now. Hang on 1 second. Alright, you have Jupiter. And what they assume is to make the models work, you need the core to be 10 to 20 times Earth mass. Okay? What that means is that this object is rocky, iron-like, hard material. And then the interior would be 20,000 degrees Kelvin. And that's the model, what they believe their modeling accomplishes. Okay? But here's what I think the actual interior is doing. Okay, you have Jupiter. Now, that's a really crappy circle. Anyways, I think you have a much larger area that is mostly undifferentiated. Okay? This material isn't really sorted out yet, and it's very, 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 very hot. And the center regions, I think, in brown dwarf stages, which Jupiter is in, much of the chagrin of establishment science, they think, this is a planet, but we all know with the theory that I'm developing, the planet is nothing but the evolving star. In other words, you have this material, which is extremely hot. I'd say at least 100,000 degrees Kelvin plus, if not more. And you have your little tiny pearl in the center. I would consider this to be the iron nickel core. This is what gives all this other object something to work off of as it cools. As well, the differences between their models and Stellar Meta is they have this inner region, this region right here, as being liquid metallic hydrogen without any evidence. That's an assumption. It's been around since the 30s. Read it. Read this book. That assumption is in there. Sorry for making the camera shake. But why did they have it like that? I don't understand. What happened to lithium? What happened to magnesium? What happened to manganese? What happened to beryllium? Okay? Where's carbon at? Where's oxygen? Where's nitrogen? Where's silicon? They're basically saying, to hell with the entire periodic table, it's all liquid metallic hydrogen. But as we know with stellar metamorphosis, this evolving star in the center, this atmosphere is going to dissipate, obviously, from radiation from a hotter host star and rip away. We have evidence of all these elements being in the interior by studying the Earth itself, which means this liquid metallic hydrogen stuff was mathematicians going crazy with math formulas. And that's that. Second point of this talk is to discuss the location of heat again. Now, I already went over this earlier, but I want to go over it again with people so they get the point. The majority of the heat of a young star, such as the sun, The sun is a young star. It wears its heart, or the majority of the heat, I should say, on its sleeve. This is where the majority of the heat of the sun is in the corona and on the surface, because as you go towards the central regions, it gets cooler. I know this is directly opposite of what establishment wants you to believe. They want you to believe that there's a nuclear burning core, and there's a radiative zone, and there's a convective zone, and all this other. They just made that up. What actually happens is that it gets cooler on the interior. And as the star gravitationally collapses, the heat, as well as the material, moves towards the center. And over time, you have an object, it's really small. They call those low mass stars or red dwarfs. Okay, red dwarfs. And what happens is, in all that heat had all that time to move towards the center gets all the heat, and the outside, that diminishes in heat. Okay, so it gets cooler on the outside because the heat moves inwards. That's simple to understand. So which means the interior of red dwarf stars is a lot hotter than the interior of young stars like the sun. And after red dwarf stage, you hit brown dwarf stage. Okay, so you have your red star, and then you have your brown star, which is like, maybe like this. Okay, so you have all your heat. It's getting hot, hot, hot. And since it continues gravitationally collapsing for the brown dwarf stage, what happens is those elements, since the outside regions of the star get really cold, and as all the heat has already gone to the center, it has time to form molecular bonds, lots of them. And a lot of the molecular bonds that are formed on the surface of this brown dwarf star also have what's called a high specific heat capacity. Meaning, once those molecular bonds form, I mean, they were forming here too. Don't get me wrong. The red star had molecules on the surface as well. Lots of them. What that does is trap the heat. So, as the gravitation collapses and the heat moves inwards, it further traps the heat. Meaning the heat cannot escape. It has a hard time escaping. And if it has a hard time escaping, as well as the star is contracting, what you'll have is the interior will heat up to extreme amounts. And that's my justification for the interiors of brown dwarf stars being a whole hell of a lot hotter than the interior of young stars like the sun. Hopefully people can understand that. Again, it helps to go to the public library and pick up books. That book was written in 1994, but a lot of the ideas in there are still taught today.